Now let us consider a rational function where the degree of numerator is higher than that of the denominator. So for this particular question, f of x is equal to 2x cubed minus 3x plus 1 divided by 3x plus 2. Now degree of numerator is 3 and that of denominator is 1. So the degree of numerator is higher. So in such cases, horizontal asymptotes do not exist. As x approaches infinity, the function also approaches infinity and therefore the horizontal asymptotes do not exist. Now let us try to prove it, right? So to prove it, what we are trying to say is what happens to the function as x approaches plus infinity or as x approaches minus infinity. If it approaches a value, then the horizontal asymptote can be written as y equals to that value, right? If it approaches undefined value like infinity, then the horizontal asymptote does not exist, right? So how are we going to solve it? So let's find the limit of this function as x approaches plus or minus infinity. So let's do that. So we have limit of this function as x approaches plus infinity, and we can write down function as 2x cubed minus 3x plus 1 over 3x plus 2. Now what we can do is we can factor out x from each cases, right? Then what do we get? Get limit x approaches infinity and we factor out x only. So we get x times within bracket 2x squared minus 3 plus 1 divided by x times 3 plus 2 over x, right? Now this x and x cancel out. So you are left with 2x squared minus 3 plus 1 in the numerator and 3 plus 2 over x in the denominator. If x is very large, then what happens to this part of the function? 2 over x. 2 over x approaches 0. So we are left with just the number 3 here, right? So we can write this as limit when x approaches positive infinity, and we have in the numerator 2x squared minus 3 plus 1 over the number 3. Now if x is very large, then the numerator is going to be extremely large, correct? It has got a factor of x squared. So as x approaches infinity, the function actually approaches infinity. As you can see, as x approaches infinity, f of x approaches infinity. It does not approach a fixed value, and therefore we can say that the horizontal asymptote does not exist, right? So in all cases where degree of numerator is going to be higher than that of the denominator, we can factor like this and then show that as x approaches plus infinity, the value of the function also approaches infinity, right? Now you could do the same calculations with negative infinity also. Let's say we did everything same, and instead of this you do x approaches minus infinity, right? That's the second case. If I write x equals to x approaches minus infinity, in that case the function will also approach, in this case since it is x squared, it will approach again plus infinity, right? So in either cases we see in this case if x approaches minus infinity, f of x approaches plus infinity in this case, right? Since we have x squared term, right? So depending on what we have here, we can decide, or we will know whether the function approaches plus or minus infinity. In either case, it is not approaching a fixed value, right? It is unbound. It is increasing unbound, right? And therefore we say that the horizontal asymptote does not exist. So in all such cases, even if we have 1 degree higher than the denominator, even then the case is going to be same. So in general, we can say if the degree of numerator is higher than that of the denominator for a rational function, then horizontal asymptotes do not exist. Okay, thank you.